Cool. Okay, so we've reached the opinion part of the talks this evening, where hopefully we're going to explore whether AI is going to take your job or not. So just by show of hands, who wants AI to take their job? Sometimes. Okay, well, we now found out in the room who has a bad job. Who doesn't want AI to take their jobs? Okay, and there's a lot of you who are very indifferent. Fair enough. If we can move forwards. So what I'm hopefully going to look at with this is how the skills around sort of building software and the resources available has actually changed over time. I think that if you actually consider the idea of is AI actually going to take your job, it's also helpful to look at what are the other innovations that have happened throughout time, and have they had an impact, adverse impact, on being able to take someone's jobs. And part of my view of this is that the core skills still remain relevant, and AI isn't necessarily going to take your job, maybe, but we'll see how we go. So a bit of high-level background to who I am and why I've got this opinion. So my name is James Ridgeway. My background is predominantly in software engineering and data science. That's the thing I've done for about the last 15 years. I currently work as CTO at a company called The Curve. We're a technology consultancy. A lot of what we do is around really helping our clients leverage technology as well as they can. That might be in a B2C setting, building out a product for someone, or being able to put together like a business critical system, or helping with sort of like IoT, connected devices, those kind of things, in sort of like a more of a B2B setting. So the best way that I can think to kind of try and explain at least my viewpoint on AI, whether it's a threat or anything like that, is actually to take a look at what's happened before. So what I'm going to talk to is my experience. There's people in the room who probably have much more experience than I. There's probably people who have much less. There may be some references in here that make no sense. So the easiest way I thought to do this was actually just to kind of take each decade that is at least relevant to me, break it down, look at what technology we had that was available to us, and how that's changed, but also how that's changed us as developers or people who work with technology. So for me, that starts with the 1990s. So towards the end of the 1990s, that's when I first started getting exposed to technology. That's when I first started playing with computers. So if we have a look at this in terms of like major programming languages that have been available over time, and if we were to actually look at sort of 1990s, it sits around about here. This is a massively simplified graph. It turns out if you Google how many programming languages are there in the world, it's about 2,000 to 3,000. What I decided to do is, rather than plot all of that, even though you get the same curve and the same distribution, is I would simplify it down to just the programming languages that GitHub is prepared to recognize, and you end up with that. But the point of the matter is that if you were to look at that sort of like 1990 point, we're saying there's around about, so that's that entire decade, there's around about 50 to 60 different programming languages, which is probably true. There's a load of stuff in there that I'd never heard of. There's probably a load of stuff in there that you've never heard of. But at that time, from what I could recall, there was about 10 main programming languages. So there's 10 main languages that people may have heard of or have interacted with or anything like that. And the thing to take away from this is there wasn't a huge amount of choice. And you can see what the choice looks like now. It's a little bit nuts. So the thing that was really critical back then is that you didn't really have Google the same way that you did now. Google only really existed in 1998, and let's face it, back then, compared to what it is now, it was a little bit shit. They've gone through some iteration over the time, but also the internet's kind of maybe grown a little bit since then. So you actually end up having to learn stuff through books. So that is actually the first book that I ever read. It was, well, not ever read, but when it comes to computing, it was the first book that I ever read. And that is 1,200 glorious pages of how to do Visual Basic 5. It is somewhat in-depth. But you couldn't really use the internet quite in the same way. You might be able to Google some stuff, what have you. The resources just, they weren't the same. It was the main way that you learn. The other thing that was really interesting is that in that era, software was closed source predominantly. We can be nitpicky and say open source started before then, and that's fine. Go and do that. But predominantly, it was closed source and everything was commercial. So the ability to share, the ability to learn, it was different. If you wanted to actually be able to access code and learn and share from examples, you had to get it in a disk in the post. So one of the first things that you kind of had was MSDN. Some people may remember this was Microsoft's solution to being able to share information with people. So you'd get a disk, one supporter. That's actually the very first one that they ever shipped in 1992. It was a bit of sort of like a prototype, but it would contain SDKs, technical articles, code samples, those kind of thing. But that was your closest thing to Googling, was waiting 3 months for the next edition to come out. So why does this matter? What's important? What's kind of the takeaway from all of this? Back then, there was much fewer choice around programming languages, frameworks, anything like that. So it was so much easier to specialize. But the other thing as well is that understanding a programming language and the fundamentals was so much more important. You know, if you had to look it up in a book every single time, that would be somewhat tedious. Googling stuff's fast, putting it into ChatGPT in some contexts is even faster. But you know, you couldn't just rely on having to look something up every single second. You actually had to learn what you were looking at, understand it, apply it. But also, typically, if you read something in a book and you try and study it in that way, you're forced by that process to actually learn what it is that you're looking at. So existing code samples were very limited. They came by post, as we all saw. And there was so much less reusability. Open source didn't really exist, at least in the way that we know it today. So being able to actually retain and recall information, that was actually important. That was a really important skill. You know, you could probably build an entire career off of that. And gaining knowledge and experience actually takes time. I think that's probably still true today. We've not really kind of solved that thing. But it was like, that was so much more important, especially when you couldn't just Google something, look it up, throw it into ChatGPT. So if we fast forward to the start of sort of like the 2000s, we kind of had a really different era. This is where the internet started to kind of take hold to an extent. We had the very first code sharing websites started to emerge. They would contain examples of code, technical articles. Some of you may recognize them. That's the very early version of SourceForge. You've got Code Project. You've got something called Planet Source Code, which I spent a lot of time looking at, trying to understand stuff and just failing, but it's all part of the learning experience. I think the other thing that's really important is like that was the main way that you learn all of this information. And we only had package managers start to be a thing in the mid-2000s. If you try and go back far enough, there are a few more examples than this, but the main example is pre-2000, Perl was the only thing that had a package manager. Everything since has kind of emerged in this era. Now, if you were to think today about a new programming language coming out and not having a package manager, that'd be nuts. What would you do? You'd have to build a load of stuff yourself. That'd be really bad. So what this shows is that over time, we've had more opportunities to share information, but also the information we've got access to has got broader and broader. And then if we go as far as 2008, 2008 was actually a really good year because Stack Overflow came out, which was going to take everyone's jobs and probably still does today to an extent, and GitHub. So this is what we all pre-ChatGPT understand as a way of sharing code, sharing resources, learning information. We've all probably seen it before. You know, internet goes down. What do people do for Stack Overflow? It's a very common concept, at least for most people. So the nature of learning, but also the nature of problem solving, really actually changed with this information. Being able to recall information was nowhere near as important because I can just Google it. I can look it up. I can go on Stack Overflow and find where 1,000 other people have asked the same question. Here's this answer that I can copy and paste. But part of what comes with this is that programming languages have been growing massively. Not only have I got an explosion in the number of programming languages I can pick from, but I've even got frameworks. I've got whole ecosystems where I could potentially actually have to learn information about. So I can't just sit at home, read a book on it, and know everything I need to know to do my job, because I might have to know the language, the framework, the front-end framework that comes with it, Docker, all of this, the cloud provider it runs on. It becomes so much more of a vast thing. But also, because of the way that package managers have grown, you don't have to build it all yourself. You can actually go out there and say, well, right, someone's solved how to do the ORM thing. I'll just get an ORM, I'll put that in my application, off I go. You don't actually have to, in this era, need to build everything from scratch. If you go back to the previous era, there wasn't, unless it came on a disk, you couldn't really share stuff much very well, at least. I'm simplifying it a bit, but you get the point, I think. There is a benefit that comes with this, which is actually that we've reduced the barrier for entry for actually being able to learn this stuff, being able to actually learn technology, engage with it, and kind of get started becomes so much more easier because resources are more available, there's more of them, and the traditional book or classroom-based approach becomes so much less critical. Your learning curve and the way that you can get started becomes drastically shortened. The main skill that I think starts to emerge during this era is it becomes less about actually being able to build stuff from scratch, but can you actually take the components that exist and the right components and combine them to actually be able to build the system or whatever it is you're actually trying to achieve. And we also start to see the emergence of Googling as a skill. It sounds a bit nuts to phrase it like this, but you can Google things well and you can Google things badly. And I think part of that comes down to how you actually frame the problem. We can all probably think about times where we've seen someone trying to search for something, and either they contain too much information or too little information, or they attribute the problem that they're trying to solve to the wrong thing. So an example to that is, one example that I saw recently was someone trying to search an error based on the program they were trying to build, but the program ran in Docker. What they didn't have the experience of or the ability to understand in what they were seeing was that actually that application isn't coming from the thing that you're actually trying to build, it's coming from Docker. So you're already Googling the problem wrong. And that's part of the problem with, like, if the barrier for entry gets lower and you're not actually understanding what it is that you're looking at, you then don't end up with the skills that you need to actually frame the problem or research it to the right depth, or even get sometimes the right starting point. So that's the 2000s. We've done 1990s, 2000s, 2010, hopefully recent enough for most of us to be able to remember this. And this is at least what I would call the real rise of open source. If you want to be a purist, open source goes back to the 1970s, but it's limited, at least compared to what we understand it today. So with open source, it was really quite a new era because you had major organizations like Facebook and Google who were open sourcing technology that was quite complex, quite innovative, and you then have the ability to leverage this just by downloading it, including it in your application, those kind of things. So we've now got sort of technology in that respect where you really struggle to build that on your own, being massively available to you, not just as a commodity, not even just as a paid commodity, but also as a free commodity, free open commodity that you can use. We looked previously at how many programming languages exist, and another thing to consider with this is the range of technology has also exploded during this area. We've got cloud, we've got containerization, we've got infrastructure as code, we've got serverless, we've got DevOps, CI, automation, machine learning, AI. The range of just different things that you've got to learn, potentially, to be able to do your job, to be able to build an application or a service or whatever it may be, it explodes massively. If you were to sit down and try and learn this from a book, how would you do it? If you had to Google it all, how would you do it and learn it from an online resource? It becomes very challenging. The rate of innovation is also changing massively. Even if we ignore everything I said there on the previous slide and said, okay, James, that's a load of rubbish, that's wrong. Even if we just focus on programming languages, this is a graph over time that shows the releases of different programming languages. I picked 3 of what I felt were reasonably common. I tried to do this with like C and C++, but it turns out they move at a glacial pace. So any graph over any timescale doesn't really work for them. So I happened to pick Python, Java, and PHP. And what this really illustrates is that during the 1990s, you had very few versions that actually emerged at all for programming languages. And once we reach that 2000 era where internet really takes off, the number of releases is it's massive, it's rapid. I mean, Python there, out of the 3 examples, is leading quite massively. PHP, which had a very dodgy upbringing, has done a huge amount of innovation. And then you've got, obviously, Java here, which has got an even lesser curve. But the point is you've got so much happening in sort of like the 2000s, the 2010s and later, that you can't really learn this stuff from books because innovation's happening too quickly. So you've got to go online, or you've got to look at other resources. You've got to be able to augment your learning somehow. So memorizing stuff in depth just gets even harder. I mean, this isn't the first time I've made this point, but it gets really quite hard. And you move away from having to understand a specific technology more towards having to understand an entire ecosystem. You've got programming languages in there, you've got frameworks, you've maybe got containerization, you're trying to run it on a cloud platform, and you're trying to manage all that maybe with infrastructure as code. And your pure bit of problem solving does get faster because you're just able to leverage what other people do. You're able to take their existing concepts, their libraries, their technologies, and use it to build a thing. So the skill set more shifts from not just can I build the thing, but it's more actually can I identify the right tool for the right job. And then we enter what we are today. So the AI era. So we're now in a world where we've got ChatGPT, GitHub Copilot, and you can arguably get working code solutions straight out of the box just by putting in what is a reasonably basic prompt. But the caveat for this is that you will arrive at an answer. Whether or not it is the right answer, there's a bit more to it than that. But it can even go, it's a good tool, because you can even get to the point where you don't really actually need to read the documentation. There's problems that I would tackle now where I would usually start with the documentation, where it's actually quite easy to start with ChatGPT and then go to the documentation later. Understanding what is right for which context is subjective. And it always has been subjective, I think, in building technology or systems. If you take an architecture problem, that's a matter of opinion. There's a right way to build something and a wrong way to build something, and the answer to that changes depending on what your focus is and the scale at which you operate. There is no binary right or wrong answer. And that, I think, in part, is where some of these tools fall down. They'll focus more on the what, but they'll entirely leave the why open to you. And it's whether, I think, we can recognise that the why is actually still something that we can tackle with. This second bullet point was put a little bit more crudely to me by someone I work with in the crude analogy of shit in, shit out. But if you put poor quality information in something, you will get poor quality information out. And I think that's very true of kind of the world that we end up with these tools. You can use them well, but you can also use them badly. And we'll see a few cases of where those have actually been used badly in a little bit. But it can be really good for pointing you in the direction of sort of like the right things to solve or the right things to look at. So I've got a colleague at the moment who's doing a lot of work around Docker, networking, and containerization. He's asked ChatGPT, how does he solve this problem? And he's got an answer out of it, a very confident answer. And it tells him that he needs to use these two different networking modes, and if he does it, it'll work. He tried it, it didn't. You check the documentation, the two networking modes, they do exist, they do the things he wants, but by the very nature of them, they're incompatible with each other. So you can't use it as part of the same solution. So the point that I'm getting at here is that all of this information becomes really easy to access, and ChatGPT, to an extent, it's a newer interface to search, but the problem even with search remains the same, that you still have to process the results once you get them. And the same, I think, is still true of ChatGPT. And what this never actually removes from is the fact that you still have to understand the fundamentals of what you're doing. If you don't understand performance, you can't build a system that's performant. If you don't understand security, you can't build a system that's secure. And if you ask ChatGPT to build something, it's not going to consider those unless you ask it to. And if you ask it to, it'll do it, but it won't consider your context. It'll do the what, it won't do the why. So we get to one of the main reasons why I think ChatGPT isn't going to take my job, which is that fundamentally, people struggle to actually really articulate what it is they want. So until we solve that, I can build an entire career out of this. And this is another example, and this isn't the real world example, but through the work that we've done through our consulting activities, we've actually answered a number of situations where people have used generative AI to generate code and put it into a production situation. Not this code, this is a fictitious example, but it mirrors the same concept. Was running in production. Can anyone spot the problem with it?
Too far away.
There is that, but I can't help that. Can anyone closer spot the problem? So what we have here, I'll explain it, just for the benefit of those who can't see it. This is a very simple implementation of an Azure function that takes some input. So it's like, I think it's like name, email, and a message, and puts it into a database table. This line here does it through concatenating a string. So anyone who knows anything about building an application in SQL will be able to tell you this is an SQL injection vulnerability. So I can put in malicious code, and I can result in very bad things happening. So as part of an engagement that we've done where we've been working with an organization, we were building a system to integrate with something they built in Azure. And we were responsible for passing them a payload. And our payload could legitimately contain an apostrophe. So in that situation, it happened to fall down because it then generated very incorrect SQL. The reality is that if you actually to build an application sensibly and with the right controls, your SQL statement should be parameterized, because if you parameterize it, you don't necessarily have to sanitize your inputs, and it's quite a safe way to do that, and you won't end up with an SQL injection vulnerability. The other example we had is an application that had been generated through ChatGPT, and it encompassed a load of business logic, but the passwords were stored in plain text. So I'll let people take away their own conclusion from that. So I think even if you weren't sold on this one, between this and the other example, ChatGPT is doing great for generating me loads of work rather than taking away from it. Anyway, so to get to the more broader point, I mean, I included those examples, but I do think it's relevant because it shows very much modern day, in this year, within the last few months, a couple of examples where sort of like it is being misused. It's being used without people thinking what they're actually trying to do. So the barrier for building software or applications and systems continues to get lower, and I do think that's a good thing. That is a good thing because in some respects it does help with accessibility, helps get with people getting started, building a new career, all of those good things. Prototyping can also get faster and faster. I've been able to build prototypes and things that I don't fully understand on the surface very, very quickly. There's a difference though. After I get so far with ChatGPT, I go elsewhere to actually validate that that's the correct and the right thing to do. And it can be a useful tool if you augment it with other resources. It does come with a flip side of challenges though, which is that understanding the fundamentals can be worryingly an afterthought. So if we take the example of either when you were learning from books in the 1990s or when you were more reliant on Googling things in sort of like the 2000s, that process of either having to read the book and study it or Google it and eventually arrive on the right answer and trial and error figure out the ones that do or don't work, it teaches you something. If you put something into ChatGPT and say, give me the code or the thing that does this, you learn just about nothing. I mean, you get code, you don't even know whether it's right or not or how many vulnerabilities it actually contains. So doing a job well still requires applying knowledge, skill, and context. That hasn't changed in any of this. In the late 2000s, a lot of people thought that Stack Overflow was coming for their jobs, and they haven't managed to do that. Learning understanding is removed from the process, kind of as I mentioned. So, that's a challenge. If you want to use ChatGPT to learn, the learning part of it is very much on your own discipline. ChatGPT is not going to do that for you. It's on how you use it. So ChatGPT Copilot is a tool like any other tool. It can be used or it can be misused. It kind of goes back to that old analogy. If you can teach someone to use a hammer, they'll see every single problem as a nail. You've got to be very careful of that. And you can get really incredible results out of it if you know what you're doing with it and you're prepared to use it sensibly. And you've got to be able to use it appropriately. As I mentioned previously, Google and Stack Overflow hasn't yet replaced developers or people who build systems. They're still around today. And my conclusion is AI won't replace developers because developers and people involved in the process will always add value. It's just the value they add will change. That will change over time because ultimately, up till this point, it's still changed. So my conclusion is AI isn't coming for your job, but a competent developer who knows how to use AI tools well may well be. That is my talk. Any questions?